In this video, I will show you how to write the standard form equation of a hyperbola given different types of information. And if I give you the standard form equation of a hyperbola, I will show you how to graph it. A hyperbola has two branches to it. Each branch has a vertex here and here. Inside each branch, there is a focus here and here. There are asymptotes that go diagonally, and the branches approach those asymptotes. Now, some hyperbolas are horizontal, meaning they open to the left and to the right, or I could say the transverse axis, this blue line, is horizontal. That's what I mean when I say a horizontal hyperbola. This hyperbola has a vertical transverse axis, so I would call this a vertical hyperbola. When the hyperbola is horizontal, the x term should be first. When the hyperbola is vertical, the y term should be first. Now, don't forget that the a value is the distance from the center to a vertex. From the center to a vertex, that's the a value. The b value is the distance from the center to a covertex, even though the covertex is not on the hyperbola. The c value will be the distance from the center to a focus. The a value and the b value will define a rectangle, and the asymptotes are the diagonals of the rectangle. Notice that the a squared denominator always is first, no matter what. So whatever is the positive fraction, we always put that in the front, and we call the denominator a squared. Whatever the negative fraction is, we call that denominator b squared. The center is just h comma k. So for problem number 1, right away they tell us that there is a horizontal transverse axis. That means the x term has to be first. So I'm going to have x minus h squared over a squared minus y minus k squared over b squared equals 1. This is the model that we use when we have a horizontal hyperbola or a horizontal transverse axis. Now remember that h and k are the coordinates of the center. So I might as well go ahead and replace the h and the k now. The opposite of this and the opposite of this. So I will put x plus 2 and y minus 3. So now all I need is a squared and b squared. Well, they were kind enough to give us a and b. So a squared will be 9 and b squared will be 64. So here is the standard form equation of the hyperbola with this center and this a and b. Okay, let's do that again for problem number 2. This time they tell us that we have a vertical transverse axis. That means that the y term is going to be first. So I'm going to have y minus k squared over a squared. A squared always goes first, minus x minus h squared over b squared. So the center is negative 9 comma 1. This is h and k. Be careful. Let me go ahead and create space for h and k, but the x coordinate of the center goes in the x part of the equation. So I'm going to put this plus 9 right here, opposite of this. And the minus 1 from the y coordinate is going to go here. The y coordinate goes in the y part of the equation. So now all I need is a squared and b squared. I knew a squared would be first. So since a is 3, then a squared is 9. Whoa, they didn't give us b. Oh, they almost snuck that in on me. Sneaky. I'm going to have to use the equation c squared is equal to a squared plus b squared. This is the relationship when you're dealing with a hyperbola. For ellipses, it's a minus. For hyperbolas, it's plus. So c squared, well, wait a minute, we know c squared. C is 6, so c squared is 36. A is 3, so a squared is 9, plus b squared. So all I need to do is subtract 9 from both sides. So that's going to give me b squared is equal to 27. I'm not going to take the square root because I want b squared. Okay, so I'm just going to put 27 right here. So this is the standard form equation of the hyperbola. Number 3, you're given the standard form equation. We just have to graph it and label all the stuff. Let's start with the center. The center is going to be the opposite of these two, but just be careful of the order. The x-coordinate of the center is going to come from the x part of the equation. So I will have -2 because of this. The y-coordinate of the center will come from the y part of the equation. So I will have -1. It's the opposite of both of these. That's why they're negative. So I've got the center at -2, -1. Let's go ahead and graph that. So -2, -1, here is the center. Next, we need to find the a value so we can find the vertices. Well, the first denominator, the denominator of the positive term, is always a squared for hyperbolas, which means that a is 4. Notice that the 16 is the denominator of the y term. So I will do my plus and minus 4 in the y direction. So starting from the center, I will go plus and minus 4. So 2, 4, and then down 2, 4. These are my vertices, ladies and gentlemen. So this is, the lower vertex is -2, -5. And the upper vertex is -2, 3. So those are my vertices. Now let's find the b value, which will lead us to the co-vertices. The second denominator, the denominator of the negative term, is always b squared. So b is 3. Notice that the 9 is the denominator of the x term. So I will do my plus and minus 3 in the x direction. So starting at the center, I will go 3 to the right and 3 to the left. So my left co-vertex is -5, -1. My right co-vertex is +1, -1. Okay. As soon as I have my vertices and my co-vertices, I actually like to go ahead and draw the rectangle that contains the vertices and the co-vertices. This rectangle shows us where the asymptotes go, because the asymptotes of the hyperbola will pass through the diagonals of this rectangle. So this rectangle has diagonals that go through here. So I'm going to have an asymptote that goes like this. Okay, see how the asymptote passes through the diagonal? Now focus your eyes on the other diagonal. So I'm going to have another asymptote that goes like this. So I can really graph my hyperbola right now. Remember, these red dots are the vertices. So that means the branches will go like this, approaching the asymptotes. So the hyperbola looks like this. We're going to need to go ahead and find the foci now, which should be floating in the interior of these branches. To find the foci, though, we will need the c value. For a hyperbola, c squared equals a squared plus b squared. So c squared will equal 16 plus 9. So c squared will equal 25. So c is equal to 5. So that will show us where the foci will be. I will go up 5 from the center. Okay, so this is 4, so this is 5 right here. Here's a focus. If I go down 5, that's going to be another focus. So this is going to be relatively simple. The coordinates of this focus are -2, comma, -6. And the coordinates of this focus are -2, comma, 4. All right, sometimes the foci can be a lot more complicated than that. The asymptotes. We need the equations, we can write one equation that will capture both asymptotes. And here's how it works. We can use the following model for the asymptotes always. We can do y minus k is equal to plus or minus m times x minus h, which is just the point-slope form of a linear equation, where we can plug in a point and the slope, and then we have an equation. M is the slope, and it's just that the point I'm using, the h comma k, is the center. Remember that the center is -2 comma -1. Don't forget that. -2 comma -1. So this is my h and my k. So this -1 is going to come right here where the k is and become y plus 1. All right, it becomes the opposite. Okay, now the x minus h. See, this -2 is going to come right here and become x plus 2. All right, it's just the opposite of this. So now all I need is plus or minus the slope. All right, look at this portion of the asymptote right here. It's easy to tell the slope. Okay, what's the rise and run from this point over to this point? Well, this is up 4 and over 3. That's why the slope is 4 over 3. And we have plus and minus because we have two asymptotes, one positive and one negative. And so that's it. That's it for number 3. I almost forgot the eccentricity on this problem. Eccentricity is just c over a, so that's just going to be 5 over 4. Kabam. Problem number 4. Let's start with the center. Opposite of this, opposite of that. The center is going to be 3, comma 1. Let's graph that. Okay, so the center is here at 3, comma 1. Now let's find the a value, which will lead us to the vertices. Of course, the a squared is the denominator of the first term, so that means a is 6. Because the 36 is the denominator of the x term, I will do plus or minus 6 in the x direction. So let's see, 3, 6, vertex. 3, 6, vertex. So -3, comma 1 is a vertex. And 9, comma 1 is a vertex. All right, let's find the b value for the covertices. We know that b squared will equal the second denominator. So b is 7. This 49 is with the y term, so I will do plus or minus 7 in the y direction from the center. So if I go up 7, I'm here. Okay, and if I go down 7, I am here. So these are my covertices. So 3 comma -6 is a covertex. And 3 comma 8 is a covertex. At this point, I like to go ahead and draw the rectangle that passes through the vertices and the covertices. So let's go ahead and draw this rectangle, which ultimately will reveal the asymptotes. So here's my rectangle. So my asymptotes are going to go through the diagonals of this rectangle. So I'm going to have an asymptote that goes like this. And I will have an asymptote that goes like this. So now I can draw the branches of my hyperbola, because these red dots are the vertices, so the branches should be located at the vertices, and then they should be approaching these asymptotes like this. So that's what the hyperbola looks like. We will need the C value to graph the foci, which should be in the interior of these two branches on the left and right. We know that C squared is equal to A squared plus B squared for hyperbolas. So C squared will equal 36 plus 49. So C squared is equal to 85. So C is going to equal the square root of 85. And for graphing purposes, this is approximately 9.2. So let's go ahead and graph those foci. All right, I have to go 9.2 to the right of this focus. Okay, so this is 3, 6, 7, 8, 9. 9.2 is going to be about here. Okay, so here are my foci. When I label these, I can't use the 9.2. I know that the y value is definitely going to be 1. See that it's up 1, so for sure I'm going to have something comma 1. For the x value, I need to consider the center. What's the x value of the center? The center is here at 3, an x value of 3. So starting at 3, all right, let me write that down. I'm going to the right, so that means I'm adding something. I'm adding the C value, right, the distance from the center to the focus, which was radical 85. So 3 plus radical 85 is actually the x-coordinate. So I have one focus, which is going to be 3 plus radical 85, comma 1, was it? Yes. Similarly, the leftmost focus will be 3 minus radical 85, comma 1. Because I'm going to start from the center, I'm going to start at 3, and I'm going to go left radical 85. So 3 minus radical 85, and the y value is 1. So that's the foci. Now how about these asymptotes? We can always use the point-slope form to find the asymptotes. If we use the center for the point, then we will have y minus k is equal to plus or minus m times x minus h, where h and k are the center. Okay, so in this case, the center is at 3, 1. Okay, I'm just going to scroll down here. So the center is at 3, 1. So this is my h and my k. So watch how the y value is going to end up right here. But I'm going to do the opposite. So this is a positive 1, so I'll end up with y minus 1 equals. And then I have the plus or minus. This m is the slope. Okay, so just pick one of the lines. What's the slope? I usually just use this point and this point. So the rise and the run. Okay, so this is that b value and the a value. So this is what? 3, 6, 7. So the rise is 7 and the run is 6. So rise over run is 7 over 6. So I will have 7 over 6 right there. And then x minus h. Okay, again, the center is 3, 1. The x coordinate of the center will show up here in the x part of this equation. So I will have x minus 3 as I do the opposite sign. And that's it. This equation actually represents both asymptotes because of the plus or minus 7 over 6. I'm getting the positive asymptote with the positive 7 over 6, and I'm getting the negative sloping asymptote with the minus 7 over 6. Okay, so point slope form. I almost forgot the eccentricity. C over A. So the eccentricity is radical 85 over 6. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.